Possible causes of the computer reboots could include transient overvoltages, which are voltage spikes or surges that exceed the equipment's tolerance and can cause sudden reboots. Voltage sags, which are temporary drops in voltage below an acceptable level, can lead to power interruptions. Frequency fluctuations, which are deviations from the standard 60 Hz frequency, can disrupt computer operation. Harmonic distortion, where high harmonic levels can overheat components and cause malfunctions. Ground faults can create voltage imbalances and disrupt power. Some diagnostic steps you can take are: firstly, monitor power quality. Use a power quality analyzer to measure voltage, frequency, and harmonic distortion. Look for anomalies during the reboots. Secondly, check power distribution. Ensure that the equipment is properly connected and grounded. Inspect wires, cables, and terminations for damage. Test for continuity and proper polarity. Thirdly, isolate the problem. Identify the affected circuits in the equipment. Disconnect non-essential devices to minimize load. If the reboots continue, the problem may be within the panel or transformer. Fourthly, contact the power company. Inform the power company about the ongoing issue. They can monitor their network for potential problems or provide technical assistance. Fifthly, consider uninterruptible power supply or UPS protection. UPS units can provide backup power during power interruptions and protect equipment from voltage fluctuations. Some additional tips include performing regular inspections and maintenance of electrical equipment. Install lightning arresters to protect against transient overvoltages. Use surge protectors for sensitive equipment. Keep the call center environment clean and free of dust, which can contribute to ground faults. Monitor temperature and humidity levels, as extreme conditions can affect power quality. Also consult with a qualified electrician for further diagnostics and resolution. When monitoring power quality, a power quality analyzer is crucial. This device captures detailed information about voltage, current, frequency, and harmonics over time. Set the analyzer to record data continuously or trigger it to record when a voltage sag or surge occurs. Analyze the recorded data to identify patterns or correlations between power quality events and computer reboots. Pay close attention to voltage sags, which are brief reductions in voltage. Sags can occur due to heavy loads starting up, such as air conditioners or large motors. Even a momentary voltage sag can cause a computer to reboot. Transient voltage surges or spikes can also cause reboots. These are often caused by lightning strikes or switching of electrical loads. Harmonic distortion can also cause problems. Harmonics are multiples of the fundamental frequency, which is 60 Hz. High harmonic levels can overheat equipment, cause circuit breakers to trip, and interfere with computer operation. Check the total harmonic distortion or THD level, which should ideally be below 5%. When checking power distribution, start by visually inspecting all wiring and connections. Look for loose connections, frayed wires, or damaged insulation. Tighten any loose connections and replace damaged wiring. Verify that all equipment is properly grounded. Use a multimeter to check the grounding impedance, which should be as close to 0 ohms as possible. A poor ground can cause voltage fluctuations and increase the risk of electrical shock. Ensure that the electrical panel is properly labeled and that all circuits are correctly identified. Verify that the circuit breakers are the correct size for the load they are serving. Overloaded circuits can cause voltage sags and trip breakers. Check the voltage at each outlet using a multimeter. The voltage should be within the acceptable range, typically 110 volts to 125 volts. Low voltage can cause computers to malfunction. When isolating the problem, start by identifying which computers are experiencing reboots. Note the location of each computer and the circuit it is connected to. If the reboots are occurring on computers connected to the same circuit, the problem is likely on that circuit. Try moving the affected computers to a different circuit to see if the problem persists. Disconnect any non-essential devices from the affected circuits to reduce the load. This includes printers, scanners, and other peripherals. If the reboots stop after disconnecting these devices, the problem may be an overloaded circuit. If the reboots continue even after disconnecting non-essential devices, the problem may be within the electrical panel or transformer. Consider using a power conditioner on the affected circuits. A power conditioner filters out voltage fluctuations and harmonic distortion, providing a more stable power supply for computers. When contacting the power company, provide them with detailed information about the problem, including the frequency of reboots, the time of day when they occur, and any patterns you have observed. Ask the power company to monitor the voltage and frequency at their transformer serving the building. They can also check for any problems on their distribution network that may be causing power quality issues. If the power company finds any problems, they will take steps to correct them. If the power company does not find any problems, the issue may be within the building's electrical system. When considering UPS protection, a UPS provides backup power in the event of a power outage. It also filters out voltage fluctuations and harmonic distortion. Choose a UPS that is appropriately sized for the load it will be serving. The UPS should be able to provide enough power to keep the computers running for at least 10 to 15 minutes, allowing time to save work and shut down properly. Install the UPS according to the manufacturer's instructions. Test the UPS regularly to ensure that it is functioning properly. Replace the UPS batteries every 3 to 5 years, or as recommended by the manufacturer. Additional tips: perform regular inspections and maintenance of the electrical system. This includes checking wiring, connections, and circuit breakers. Clean the electrical panel regularly to remove dust and debris. Install lightning arresters to protect against voltage surges caused by lightning strikes. Lightning arresters should be installed at the service entrance of the building. Use surge protectors on all sensitive electronic equipment. Surge protectors can help to protect equipment from voltage spikes. Keep the call center environment clean and free of dust. This can accumulate on electrical components and cause them to overheat or malfunction. Monitor temperature and humidity levels in the call center. Extreme temperatures and humidity can affect the performance of electrical equipment. Ensure that the call center is properly ventilated to prevent overheating. If you are not comfortable working with electricity, consult a qualified electrician for assistance. Electricity can be dangerous, and it is important to take precautions to avoid electrical shock. Also, consider the age of the equipment. Older power supplies in computers may become more susceptible to voltage fluctuations. A failing power supply in one computer can sometimes introduce noise into the electrical system, affecting other devices. Replacing aging computer power supplies might resolve some of the issues. Check for electromagnetic interference or EMI. Sources of EMI, such as nearby radio transmitters or industrial equipment, can sometimes interfere with electronic devices. Shielding cables and equipment can help reduce EMI. Also check the building's main electrical panel for any signs of corrosion, water damage, or overheating. These conditions can indicate underlying electrical problems. If other businesses in the same building or area are experiencing similar issues, it could point to a problem with the utilities grid. Power companies sometimes experience issues with their equipment that can cause fluctuations. Be sure to document all findings, actions taken, and communications with the power company or electricians. This documentation can be helpful for future troubleshooting and analysis. If the call center has backup generators, test them regularly to ensure they are functioning correctly. Generators should be properly maintained to provide reliable power during outages. Check the power factor of the electrical system. Low power factor can lead to voltage instability and increased energy consumption. Correcting power factor can improve the overall efficiency of the electrical system. Consider using a dedicated neutral and ground system. This can help to reduce noise and improve the reliability of the electrical system. Ensure that all electrical work is performed by qualified and licensed electricians. Improper electrical work can create safety hazards and increase the risk of equipment damage. Review the call center's electrical load profile to identify any potential overloading issues. Overloaded circuits can cause voltage sags and equipment malfunctions. Consider using energy-efficient equipment to reduce the overall electrical load. Energy-efficient equipment can save money on electricity bills and reduce the strain on the electrical system. Regularly inspect the uninterruptible power supply batteries for signs of degradation or damage. Replace batteries as needed to ensure reliable backup power. Ensure that all electrical panels and equipment are properly grounded to prevent electrical shock hazards. Grounding provides a path for fault currents to flow safely to ground. Consider installing a whole-house surge protector to protect against transient voltage surges. A whole-house surge protector can help to protect all of the electrical equipment in a call center. Also investigate the possibility of shared neutral connections. Improperly shared neutral connections can lead to voltage imbalances and equipment problems. Check the neutral to ground voltage at various points in the electrical system. High neutral to ground voltage can indicate problems with the grounding system. Ensure that all electrical codes and regulations are followed. Compliance with electrical codes helps to ensure the safety and reliability of the electrical system. Consider using a power quality monitoring system to continuously monitor the electrical system. A power quality monitoring system can provide early warning of potential problems. Be aware of any recent changes in the call center's electrical load. Adding new equipment or appliances can overload circuits and cause voltage problems. Ensure that all employees are trained on basic electrical safety procedures. Training can help to prevent electrical accidents and injuries.